it up.
Point it up. Ready, set, go.
Turn.
Turn the damn thing.
You gotta do it again. 3, 2, 1, go. There we go. One, go. 1, 2, 3, 4.
I didn't lose sight of it. It's right in here somewhere.
Just take all the grass.
That makes sense? Yeah. Alright, let's do. Damn it!
Fuck.
Hello.
Oh man.
So we started by making a diagram of our cannon shot, the initial height of the barrel and the distance x that the ball bearing was fired. Using the known angle theta of the shot, which was 60 degrees, and measured distance, we use this equation that shows the height of the projectile as a function of the distance x, gravity, velocity squared, theta, and distance again to derive an equation that would let us calculate the initial velocity. Using that initial velocity and theta, we were able to calculate the initial velocity in the x direction and initial velocity in the y direction. Initial velocity in the x direction is the same as the final velocity in the x direction. However, to calculate the final velocity in the y direction, we had to use our initial velocity and add into it the effects of gravity from that initial y value that we had. Using this data, we were also able to calculate the initial kinetic energy and the initial potential energy, which was the same for all shots because the mass of the ball remained the same and the initial y value was always 0.45 meters.
Action.
Alright, now that Lars has gone over the calculations or equations that we use to calculate our numbers for our experiment, I'm going to go over our data and then how we applied that data. So here we start by just taking all of our shots and collecting data. So we took 12 different shots. We had 4 shots to calculate the best method that we used. We found the best method on the second try, which was dropping 7 Mentos in and allowing the pressure to build for 4 seconds. And that allowed us to get a distance of 12.5 meters. So once we found that method, we replicated that and ended up getting a pretty large data set. We have from 17 to 29 meters. So 29.5 being our max in this case, and 12.5 meters being our min. So once we found that, we then level plane range, came up with a total mean distance of 18.72 meters. So with the 18.72 meters, we should be able to see that there is a peppering of shots in a radius around that number. And as you can see, we have a 17.01, a 17.5, and some 20s. which is a radius around 18.29, or sorry, 18.782. So, say it worked out.